Trying to land on the moon is hard. Without an appreciable atmosphere, you can't slow yourself down using drag from a parachute or using lift from a wing or spinning rotor. But what you can use is thrust. For the safe landing on the moon challenge, we will be using thrust from a balloon to slow the descent of a model lander as much as possible. For my first prototype, I'm starting with a ring made from the top of a foam cup as a frame for my lander, then adding landing legs made from bendable soda straws. To try to make the lander as stable as possible, I'm adding some feet made from the bottom of foam cups to each landing leg, as well as extending the legs by adding some additional length. I'm trying to make the lander as lightweight as possible. Even though gravity accelerates everything downward at the same rate, the downward force is still dependent on the mass of an object. So a heavier lander would take more thrust to slow its descent. After adding the last of the feet, we're ready to attach our balloon. You'll need to roll the end of the balloon and seal it with a binder clip, then carefully line it up and attach it with tape. To test our design, first we'll drop our lander with the balloon sealed to get a baseline time and to ensure it survives the drop. The activity calls for the lander to be dropped from a height of 2 meters, but to get it tested in frame, we're going to drop it from a height of 1.3 meters. Then we'll release the clip and allow it to fall with the help of the thrust of a balloon. Okay, that was pretty unexpected. As you can see, we actually had too much thrust for the weight of our lander. Now we can't really change the amount of thrust of the balloon, but we can add more mass to our lander. So for my next design, I'm using part of a cardboard box for my frame and reusing the landing legs from the first prototype. Ouch, let's try that again using some balloon thrust. Nope, our new frame is just too heavy for our landing legs. So let's reinforce them using some pipe cleaners. While we're at it, I'll add a little aluminum foil and a NASA decal to spruce up our final design. Okay, that looks promising. Now with some thrust. Finally, a successful landing. As you can see, it took a few iterations of the engineering design process to create a prototype that mostly worked. But I know you can do better. That's why I challenge each of you to click in the link in the description below and take the Safe Landing on the Moon challenge. And don't forget to share your results at #NextGenStem.